In the history of car manufacturing, Tesla is the only company bold enough to bring a machine the size of a 4-story building into a factory. China has tried multiple times to replicate Tesla's production line, especially the Giga Press machine to speed up EV manufacturing. But it seems the 9,000-ton Giga Press is the biggest they've been able to copy so far. Now Tesla has taken things to a whole new level by deploying a 50,000-ton Giga Press to produce 5 next-gen vehicles in a single casting, with each mold taking just a few seconds at incredibly high output. That means every minute, nearly 5 Teslas roll off the line, just like Elon Musk emphasized.
I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Sounds like an exaggeration, right? Even the cheapest cars usually take close to a minute just to roll off the line. 5 seconds? That's like a car shooting out of the machine like a bullet from a gun. You might not believe it, and honestly, neither did we at first. But this machine is real, and it's going to put massive pressure on Chinese automakers. Why? Let's break it down right now. You might not know this, but the Tesla Giga Press is a rather strange machine. Despite its massive size and weight, thousands of tons, and a wide array of different systems, what happens inside this machine truly left us speechless. The operation of the 50,000-ton Giga Press could easily be considered an engineering marvel in 21st century automotive manufacturing. At its core, the Giga Press is a high-pressure die casting machine, and this isn't a new manufacturing process invented by Tesla. Casting has long been a crucial part of the automotive industry throughout its history. It's been used to create vital components like engine blocks, transmission cases, and front or rear frame sections for electric vehicles. However, what's unprecedented is a single casting machine being able to cast both the front and rear frames of an entire vehicle's underbody in one go. That's something the industry has never seen before. The highest clamping force ever achieved by a die casting machine is 50,000 tons, and Tesla will be the only company to take advantage of this machine to produce its highly promising next-generation vehicles. According to Elon Musk, these vehicles will be sold at affordable prices, which means demand will be massive. Tesla needs a machine that can manufacture fast enough before they're faced with millions of orders. Tesla has already used a 6,000-ton casting machine to produce the rear frame of the Model Y, and a 9,000-ton machine to cast the frame of the Cybertruck. Both machines have proven effective in reducing costs, speeding up production time, and delivering highly efficient underbody for the Model Y and Cybertruck. So it's no surprise that Elon Musk wants to scale this efficiency across all of Tesla's new models using an even larger system. While a traditional die-casting machine typically has just one mold, the 50,000-ton press will have at least 5 molds, allowing it to cast 5 underbodies in a single cycle.
In a single casting machine, we could do like 5 at a time or something. I'm trying to think, like, how do you scale castings? Because you got liquid metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
The molding process of the 50,000-ton press used by Tesla is also more advanced than that of standard casting machines. We'd even say it's more complex. Understandably, with more molds, the aluminum metal has to travel farther, which increases the chances of defects. If the injection is too fast, air bubbles can form in the metal, compromising the structural integrity. But if it's too slow, the metal may start to cool before fully filling the mold, resulting in incomplete or uneven parts. That's why the casting system of the 50,000-ton Giga Press must operate with extreme precision, down to the exact second, the exact millimeter, or even more. First, a new aluminum alloy, along with leftover aluminum from previous castings, is heated to 850 degrees Celsius in a melting furnace. The solid aluminum blocks quickly melt down into liquid aluminum in this furnace. The molten aluminum is then transferred to a holding furnace, where the temperature is kept stable between 750 degrees Celsius and 850 degrees Celsius. To ensure quality, the furnace chamber is filled with nitrogen gas to prevent oxidation, while argon gas and a silicon carbide filter are used to remove impurities. Before each casting cycle, a thin layer of soybean oil is sprayed onto the mold to make it easier to release the vehicle frame once it's complete. A vacuum system removes air from the mold, and then the molten aluminum is injected into the mold cavity at extremely high speed by a high-speed piston. This process requires absolute precision. If the aluminum is injected too fast, Air bubbles can form and ruin the part. If too slow, the metal may cool before the mold is fully filled. Once the molten aluminum is injected, the mold is rapidly cooled, and the vehicle frame is extracted at around 400 degrees Celsius. It's then placed into a cooling tank to bring the temperature down to about 50 degrees Celsius. Finally, a robot cleans the mold and prepares it for the next cycle. This is a basic and easy-to-understand overview of how the 50,000-ton Giga Press works. While everything in reality is far more detailed and complex than what we've just described, this is the simplest way to visualize the operating mechanism of this massive machine. As we mentioned earlier, Tesla won't be using the 50,000-ton Giga casting technology for the Model Y, Cybertruck, or Model 3. Instead, it will be used to manufacture two next-generation vehicles, the Cybercab and Model 2. These cars are significantly smaller than the current models, and the goal of this massive machine is to cast the entire underbody of the vehicle in a single shot, including both the front and rear frames. This not only saves time but also eliminates dimensional errors and makes the assembly process much easier. Okay, if the 6,000-ton Giga Press was already an engineering feat, then the 50,000-ton Giga Press represents a groundbreaking leap forward. With the ability to generate 8.3 times the pressure of the 6,000-ton version and 5.5 times that of the 9,000-ton version. Casting 5 Model 2 and Cybercab underbodies in a single shot is completely achievable. The Model 2 and Cybercab will share about 70% of their design and dimensions, featuring a compact form with short front and rear overhangs. Compared to the Model Y, which has over 200 structural components, these two vehicles will use only around 80 parts, a reduction of more than 60%. This dramatically simplifies the assembly process and significantly lowers production costs. According to Elon Musk, the production line using the 50,000-ton Giga Press operates so fast that humans can't even get close. The entire process, from melting the aluminum to high-pressure casting, mold cooling, and frame removal, is fully automated.
The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. In fact, the line will move so fast that actually people can't even get close to it.
For the entire underbody of these two vehicles, there's no method that can effectively replace casting. A typical vehicle frame is usually made up of many stamped parts. Stamping is much simpler than casting. You just take a flat sheet of metal and press it into shape, using a tool with the desired form. Then you have to join dozens of these stamped parts together by welding, riveting, or even bonding them to create a complete frame. This process is quite complex and labor-intensive. The Giga Press has revolutionized this process by eliminating all the complex steps and replacing them with one massive machine that performs a single powerful action to produce the final product. Not only is it faster, but it also delivers greater consistency and superior quality. Most importantly, every time you join separate parts together, you create connection points that are prone to cracking or failure. The Giga Press eliminates those weak spots, resulting in a much stronger and more reliable frame for the Model 2 and Cybercab.
So I mean, we got to jam the liquid metal in, cool it down real fast.
Compared to earlier versions, the 50,000-ton Giga Press is equipped with an ultra-fast cooling system, an intelligent mold release mechanism, and a cutting-edge AI-powered quality inspection system. This system analyzes X-ray images and real-time data from temperature and pressure sensors to detect defects with high accuracy, without any human intervention. It's a breakthrough compared to the 6,000-ton and 9,000-ton Giga Presses, which were advanced in their own right, but didn't reach this level of deep automation. Although the 50,000-ton Giga Press is massive and even requires a specially built facility for installation, it makes up for it by eliminating the need for many other robots on the production line. A single 50,000-ton Giga Press could allow Tesla to remove over 1,000 redundant robots. Currently, Tesla's Gigafactory Shanghai produces one Model Y every 33 seconds, according to Lars Moravy, Tesla's VP of Vehicle Engineering. What does this mean? With a minimalist design and an optimized production line, the Model 2 and Cybercab could reach unprecedented production speeds. If Tesla deploys two production lines, each producing a frame every 5 seconds, The company could manufacture up to 178,000 vehicles per week, equivalent to more than 7 million cars per year. You might not know this, but the journey of the Giga Press to Tesla is quite a dramatic story. It all started with what seemed like a simple problem, but was actually a major bottleneck in car manufacturing. Welding car frames was taking too much time and labor. One day, Elon Musk looked at Hot Wheels toy cars, which are made from a single die-cast piece, and asked himself, why can't we do the same with real cars? That question sparked the idea that led to the creation of the Giga Press, a massive die-casting machine capable of producing an entire vehicle frame in a single shot. However, turning that idea into reality wasn't easy. Tesla approached 5 of the world's top die-casting machine manufacturers, but all of them rejected the concept, believing Musk's idea was impossible. It wasn't until Tesla reached out to Idra Group, an Italy-based company under the LK Technology Group, that they finally got a hopeful response. It's possible. From there, Tesla and Idra worked tirelessly for over a year to develop the Giga Press. The result was the first 6,000-ton Giga Press, which was put into operation at Tesla's Fremont factory in late 2020 to produce the underbody of the Model Y. It's fascinating to see how Tesla tackled the challenges of large, single-piece die casting, and this machine has proven to be a game-changer. While competitors like General Motors, Hyundai, Volvo, Zeekr, and XPeng are also investing in die-casting technology, only Tesla has dared to push the limits with a 50,000-ton machine. There's been a challenge that has puzzled automotive engineers for over a century. How do you build a high-quality, consistent car while doing it as quickly and as cheaply as possible? In the 20th century, Henry Ford changed the world with his solution, the assembly line. Now, in the 21st century, we have the Giga Press. Clearly, the 50,000-ton Giga Press is more than just a machine. It's a symbol of Tesla's relentless innovation and ambition to lead. By turning an idea inspired by toy cars into reality, Tesla isn't just building the Model 2 and Cybercab, affordable EVs for the masses, it's redefining how the world manufactures automobiles. With unprecedented speed, precision, and automation, the 50,000-ton Giga Press is proof that Tesla isn't just competing, it's shaping the future. Chinese automakers have a long history of learning from and adapting the technologies of global competitors. In the past, they were often criticized for copying designs and technologies from Western and Japanese brands. But over the past decade, they've made major investments in R&D to build their own innovation capabilities. The Giga Press has now become an attractive target for Chinese automakers after seeing the benefits Tesla has achieved with the machine. However, one of the biggest challenges Chinese automakers face is replicating the special aluminum alloy Tesla uses. Developed with support from SpaceX's materials engineering team, this alloy isn't just strong, it also flows smoothly during casting, resists corrosion, and offers high ductility, eliminating the need for heat treatment after casting. Reproducing this alloy requires advanced materials engineering expertise, something Chinese companies are striving to achieve through investments in R&D and partnerships with research institutes. BYD is looking to develop proprietary alloys tailored for its own electric vehicle applications, with a strong ambition to surpass Tesla in the long run. From our perspective, Chinese automakers truly possess distinct advantages. The massive domestic market provides the scale necessary to test and roll out new technologies efficiently. In addition, the Chinese government strongly supports the EV industry through subsidies, tax incentives, and investments in infrastructure, creating a favorable environment for companies like NIO and XPeng to access the capital needed to develop cutting-edge technologies like the Giga Press. Some companies are also exploring alternative approaches such as using smaller casting machines combined with advanced assembly techniques to achieve similar efficiencies without directly replicating the Giga Press. However, simply copying the Giga Press may not be enough for Chinese automakers to surpass Tesla. The Giga Press is more than just a machine. It's a key component of Tesla's holistic manufacturing philosophy, which emphasizes process simplification, efficiency, and relentless innovation. While Chinese companies are growing rapidly, they are often criticized for prioritizing speed and cost over long-term quality and durability. To truly compete with Tesla, they must not only replicate Tesla's technologies, but also develop their own unique innovations. For instance, BYD has pioneered its blade battery technology, offering advantages in energy density and safety. Integrating such innovations with Giga Press-like manufacturing techniques could help Chinese companies differentiate themselves and stand out in the global EV market. The race to replicate the Giga Press also reflects a broader trend in the automotive industry: the shift towards smart, highly automated manufacturing. Chinese automakers, with their agility and access to resources, are well positioned to capitalize on this trend. However, to succeed, they must overcome technical, regulatory, and strategic challenges, while also fostering a culture of innovation similar to Tesla's. Can competitors catch up? Maybe. But for now, Tesla is already far ahead with its 50,000-ton Giga Press. Meanwhile, the Tesla Model 2 is a strategic product designed to bring electric vehicles closer to the mass market. With a price point of around $25,000, the Model 2 could help Tesla achieve its goal of making EVs mainstream, offering an affordable and eco-friendly solution for everyday consumers. With its superior performance, long driving range, and advanced tech features like autopilot, the Model 2 is expected to attract a large wave of new customers and further accelerate the global transition to electrified transportation. On the other hand, the robotaxi Cybercab represents a large-scale autonomous ride-hailing network. It's expected to deliver convenient, cost-effective transportation through fully self-driving vehicles. Operating 24/7 without a human driver, the Cybercab would significantly reduce operating costs while offering fast, safe service. Both of these products not only reinforce Tesla's leadership in the automotive industry, but also pave the way for an entirely new business model, one that meets the growing demand for low-cost EVs and autonomous transportation services. We hope we've helped you gain a clearer understanding of the Tesla Giga Press machine and the molding process. Let us know in the comments below what you think about this machine. Do you think Tesla will roll out even larger casting presses in the next decade? And don't forget to hit the like button if you enjoyed this video. It really helps our content reach more people. The Tesla dog robot project has been hyped up for a while, and Elon Musk finally confirmed on X that Tesla dog is being tested at Giga, Texas with a bunch of useful tasks following Optimus. Alongside the humanoid Optimus robot, Tesla's gearing up to drop a dog robot with some pretty cool features, like a way to stop vandals and attackers targeting Tesla stores by Musk haters. It hasn't officially launched yet, but the Tesla dog robot's already got some jaw-dropping features and tech. Way more than we expected, at least 6 of them. If Tesla starts selling this dog robot, we're betting it'll keep your house safe as hell. Of course, Tesla's not the first to make a dog robot. Other companies like Boston Dynamics with their Spot Dog or Unitree's Go 2 are already out there. So Elon's not just trying to compete. Building the Tesla dog is a must for his big picture vision. The timing's no coincidence either. Tesla's been dealing with a ton of vandalism at their stores, and Tesla cars keep getting torched. Price-wise, the Tesla dog might only cost about a quarter of what Optimus does since it's got way fewer parts. Musk said the Tesla bot, Optimus, runs $20,000 to $30,000, so the dog robot could be around $5,000. That's cheap enough for pretty much anyone to grab one. Alright, so what's the deal with Tesla's dog robot? What features does it have, and how did Tesla build it? As Elon confirmed back in May, he's sticking with Tesla for at least another 5 years, which means the attacks on Tesla and its products aren't slowing down anytime soon. Recent clashes between Elon Musk and Trump have only made things messier. Okay, believe it or not, the Tesla dog robot project has been in the works since Elon first planned to launch Optimus. Back then, Boston Dynamics was stealing the show with their Spot Dog, built to handle all sorts of environments, from industrial sites to research and rescue missions. But instead of jumping on that bandwagon, Tesla focused on Optimus first. Why? Because Elon figured if they could nail a humanoid robot like Optimus, adapting that tech to make a dog robot would be a piece of cake. Basically, it's way easier to transfer tech from a human-shaped robot to a dog bot than the other way around. Put simply, the Tesla dog robot will use the same drivetrain, battery, joints, sensors, and AI system found in Optimus, but in a more simplified form. As Elon Musk explained, to bring robot production costs down as much as possible, Tesla has heavily reused engineering from its electric vehicles for Optimus, and now from Optimus to the Tesla dog.
Everything we've developed for our cars The batteries, power electronics, the advanced motors, gearboxes, the software, the AI inference computer, it all actually applies to a humanoid robot.
Elon Musk's goal is to create a robot dog that's not only smart, but also more agile and significantly more affordable, like we mentioned earlier, around just $5,000. Yeah, compared to other robot dogs like Boston Dynamics Spot or the Unitree Go 2, the Tesla dog is truly much more budget-friendly. Looking at Boston Dynamics Spot, although it has proven useful in tasks like safety inspections and industrial monitoring, it still has some major limitations. With a price tag of up to $74,500, limited battery life, and less than ideal performance in highly intelligent tasks, Spot doesn't quite meet all the demands one would expect from a true robotic dog. Meanwhile, the Unitree Go 2 can perform tricks like waving, jumping, and flipping, but its real-world interaction capabilities are still limited. It can't automatically wake up when needed or carry out tasks like patrolling or surveillance without human intervention. Looking at the Tesla dog, it grabs your attention right off the bat with its sleek, modern look. Unlike those clunky robots that seem like a bunch of metal parts slapped together, Tesla dog's got a clean, polished vibe that keeps its weight low and makes it super easy to move around in any setting. If you've followed Tesla's product design over the years, you'll notice everything they make. EVs, humanoid robots, or this dog bot has that super minimalist style. But don't get it twisted. Minimalist doesn't mean cheap or rough. Even when you put a Tesla car or robot next to its competitors, Tesla's stuff always stands out as the sharpest. Based on the info we've got, the Tesla dog robot comes in at a solid 40 inches long, 19.2 inches wide, and 25 inches tall when it's on the move. Compared to Boston Dynamics Spot Dog, which clocks in at 43.3 inches long, 19.7 inches wide, and 24 inches high, the two are pretty close in size. Sure, the Tesla dog is a bit shorter, but that's actually a win. It lets the robot dodge obstacles like a pro and makes it a better fit for tight spots like homes, retail stores, offices, or cramped factory floors. Sources from the Tesla dog robot engineering team revealed that Elon Musk specifically requested the robot's weight be optimized as much as possible, from 90 pounds down to just 65 pounds, including the battery. According to Musk, the Tesla robot dog strikes an ideal balance between agility and stability on uneven terrain. This makes it especially well-suited for use in Tesla stores. A lighter weight allows for smoother movement, but the robot must still be heavy enough to remain stable and avoid losing balance while traversing obstacles. Tesla dog comes in two colors, black and white, just like the Optimus robot. It's also built using high-end composite materials, with an aluminum frame covered by a plastic shell. This provides outstanding durability while keeping it lightweight. That not only makes it easier to operate, but also ensures long-term reliability. More importantly, a simple, intuitive design that's easy to mass-produce is a top priority for Elon Musk with this project. So, what do you think of the Tesla dog robot's design? Surprisingly, Tesla dog actually has a head that resembles a real dog. If you've seen the Unitree Go 2, you might have noticed its head looks a bit strange, and Boston Dynamics Spot doesn't even have a head. Tesla's decision to give the robot a dog-like head makes it feel more friendly and approachable. At least, your kids won't be scared when you bring a robot dog home. With Optimus, most people said it moves quite slowly, only about 1.2 meters per second, which is partly due to its 138-pound weight. However, Tesla dog stands out not just for its sturdy design, but also for its superior mobility compared to competitors. It's equipped with flexible joints powered by ultra-compact, integrated actuators. The robot dog's legs allow for smooth movement, making it easy to change direction and navigate obstacles. With a top speed of 1.8 meters per second, Tesla dog is actually faster than both the Unitree Go 2 with 1.5 meters per second and Boston Dynamics Spot with 1.6 meters per second. Tesla dog's eyes come equipped with a high-res 2D camera, delivering a full 360-degree view with a range of up to 20 feet. This lets Tesla dog not only map its surroundings with pinpoint accuracy, but also optimize its movement and navigation. The camera system works reliably even in low-light conditions, ensuring top performance around the clock. Tesla has a proven track record of building cutting-edge sensor systems, and Tesla dog is no exception. Like the Optimus robot, Tesla dog is decked out with full-body sensors from head to toe. These sensors don't just spot obstacles and prevent collisions, they also maintain safe distances for smooth, precise movement. What sets Tesla Dog apart, though, is its thermal sensors. These can detect heat sources, like human or animal bodies, even in complete darkness or dim environments. This isn't just a nice aim-to-have feature, it's a practical necessity, since most break-ins at Tesla stores happen at night. With this capability, Tesla Dog can spot intruders and sound the alarm in real time, boosting property protection and ensuring security during critical situations. Packing Tesla Robot Dog with a ton of sensors makes it a game-changer for tasks like nighttime patrolling or standing guard, taking over jobs humans would usually handle. Some reports even say its AI, paired with a speaker system, lets Tesla Dog pick up sounds beyond just commands. Think fire alarms, cries for help, or signs of an attack. Built with top-notch materials, Tesla Dog boasts an IP60 rating, meaning it can shrug off dusty environments without a hitch. It's also tough enough to handle extreme temperatures, from -4 degrees Fahrenheit to 131 degrees Fahrenheit, making it insanely durable in harsh conditions. Tesla Dog runs on a 1.2 kilowatt-hour battery pack, powering it for 6 to 8 hours of continuous use, depending on the task. That's a big leap over Boston Dynamics Spot, which taps out at about 2 hours. With Tesla Dog, you get long-lasting performance without the constant need to recharge, perfect for extended missions. With its 1.2 kilowatt-hour battery, Tesla Dog doesn't just optimize performance, it keeps things lightweight, making it super agile. Compared to Tesla's humanoid Optimus robot, which rocks a 2.3 kilowatt-hour battery, Tesla Dog's smaller pack ensures nimble movement without sacrificing range. For tasks like patrolling or light navigation, it can run for up to 7 hours straight without a hiccup. And like Optimus, it supports wireless self-charging through custom docking stations, so you can skip the hassle of plugging it in every time. Tesla Dog's AI, trained on Tesla's beastly Dojo supercomputer, uses the same deep learning algorithms as their self-driving cars. Its brain has been fed thousands of real-world images and data, letting it map environments, identify objects, and analyze human or animal behavior. It can spot intruders nearing key areas like Tesla dealerships, recognize faces, and even detect weapons that might be used for vandalism. After analyzing behavior, Tesla Dog can record and send instant alerts to security teams. On top of that, as we mentioned earlier, Tesla Dog can recognize voices and sounds, letting it process complex commands and respond accurately and fast. Don't get it twisted. It can't talk like Optimus since it doesn't have Grok voice, but it can understand instructions and react efficiently. Tesla Dog's 2D camera doesn't just let it see its surroundings, it records continuously, day or night. Paired with its thermal and audio sensors, it can pick up odd movements or sounds like breaking glass or sneaky footsteps, triggering instant security alerts or sounding an alarm automatically. This capability doesn't just protect property, it keeps security staff safer, especially in tense or dangerous situations. With its quick reactions, Tesla Dog helps cut risks and shields people in scenarios where lives could be on the line. That said, everything we know about Tesla Dog so far comes from leaked info by folks close to the project. Tesla might make plenty of tweaks and upgrades before officially launching Tesla Dog next year. For now, Tesla's focus and resources in 2025 are zeroed in on cranking out Tesla Optimus, aiming to produce at least 5,000 units as Elon Musk has claimed. Now we'd like to briefly talk about Optimus, since Tesla is planning to release it next year, and many customers are starting to ask questions about the Tesla bot's ability to take on a wide range of tasks. Unlike traditional robots that require pre-programming or remote control, Tesla's Optimus has the ability to learn in ways we've never seen before. With the capability to watch instructional videos on YouTube, this robot can learn up to 100 new tasks per day, from simple chores, like sweeping the floor or doing the dishes, to more complex skills like operating machinery or cooking a delicious meal. For example, to learn how to make a sunny-side-up egg, Optimus just needs to watch a chef on YouTube prepare the ingredients, turn on the stove, and crack an egg into the pan. It will observe the process a few times, try it out itself, and gradually adjust its technique to get near-perfect results. This learning process may take only a few minutes for simple tasks, or a few hours for more complicated ones, but it's still hundreds of times faster than traditional robot training methods. This capability not only offers unprecedented flexibility, but also makes Optimus a powerful assistant across a wide range of settings, from the home to industrial environments. What truly sets Optimus apart is its ability to learn directly from humans. No programming skills or specialized equipment required. This approach makes Optimus more user-friendly and accessible than ever before. You don't have to be a tech engineer. Anyone from stay-at-home parents and factory workers to retail employees can become a trainer for Optimus. This opens up limitless potential for its applications, from assisting with household chores to optimizing production processes in factories. One of Optimus's most groundbreaking features is its collaborative learning system. When one Optimus learns a new skill, it uploads that knowledge to Tesla's shared software network. Instantly, every other Optimus around the world can access and perform that same task without having to learn it from scratch. Just imagine, if an Optimus in a California factory learns how to assemble an electric vehicle component, every Optimus in Shanghai or Berlin will be able to do the same thing in a matter of seconds. This system creates a collaborative learning network, allowing the entire fleet of robots to improve at an exponential rate. If Tesla deploys 1,000 Optimus robots, and each one learns a new task every day, the system could accumulate 1,000 new skills daily, rapidly, building a massive skill library. This not only makes Optimus more efficient, but also enables it to take on complex tasks like synchronizing movements for group dances, a clear demonstration of the system's consistency and intelligence. In the service industry, Optimus could take on roles as an intelligent sales associate, assisting customers in real time, or work in restaurants handling serving and cleaning tasks. In agriculture, it could plant seeds, water crops, harvest produce, and monitor plant health. These capabilities not only boost productivity, but also reduce reliance on manual labor, delivering significant economic benefits. According to a recent report by Morgan Stanley, replacing just 10% of Tesla's workforce with Optimus could save the company $2.5 billion. Each robot has an estimated net present value of $200,000, highlighting the massive economic potential of Optimus. In the service industry, a restaurant using Optimus could significantly cut labor costs by having the robot serve food, clean up, or assist in the kitchen. In manufacturing, Optimus could boost productivity by 20 to 30% thanks to its ability to work 24/7 with high precision, while also lowering maintenance and training expenses. Elon Musk envisions Optimus as a mass-market product with an affordable price. He estimates that the retail price of Optimus will range from $20,000 to $30,000 once large-scale production is underway, significantly cheaper than other humanoid robots like Boston, Dynamics, Atlas, or Figure AI's Figure 002, which typically cost over $100,000. However, some sources suggest the initial price in 2026 could be higher, around $40,000 to $50,000, due to production costs and supply chain challenges, particularly for components imported from China. Tesla aims to reach the $20,000 price point once annual production hits 1 million units. Tesla also plans to offer an Optimus rental service, allowing users to experience the robot at a lower cost. While the official rental price hasn't been announced, some speculation on X suggests it could be around $400 per month. This is a smart strategy to make Optimus more accessible and encourage users to try it before committing to a purchase. As impressive as Optimus's rapid learning capabilities are, they also raise important safety concerns. What happens if the robot accesses videos that teach dangerous skills, like using weapons or committing acts of sabotage? To address this, Tesla will need to implement advanced AI filters to screen video content before Optimus learns from it. Videos containing keywords like weapons or violence would be blocked based on both contextual and visual analysis. Additionally, Tesla could restrict the sources Optimus is allowed to learn from, for example, limiting it to official YouTube channels, Tesla's proprietary training materials, or pre-approved user-submitted content. In a market crowded with humanoid robots, Tesla's Optimus stands out with its unprecedented learning capabilities and its role as a true household assistant. With the ability to learn 100 tasks per day from YouTube, Optimus not only outpaces its competitors but also redefines how we think about automation. From assisting with household chores and revolutionizing manufacturing to enabling entirely new business models, Optimus is on track to become one of Tesla's most iconic products. While it still requires time to be fully refined and is expected to launch in the third quarter of 2026, Optimus has already proven that the future of humanoid robotics isn't just intelligent, it's genuinely useful. Above all, both the Tesla Dog robot and Optimus are very exciting. Will you buy them? EV expert Sandy Munro once remarked that solid-state batteries are the kiss of death for gasoline and diesel, as they are the most promising type of battery capable of enabling EVs to reach up to 1,000 miles on a single charge. This also means they pose a serious threat to Tesla's 4680 battery, which is currently considered the best EV battery in the world. With the superior power of solid-state batteries, Toyota, as a pioneer in this technology, is confident it can surpass Tesla. The company boasts a 700-mile range and a full charge time of just 10 minutes. Toyota believes solid-state batteries will be a major breakthrough, making them more mainstream than Tesla's 4680 battery, and that Elon Musk will fall behind if he doesn't get on board with solid-state tech. However, in our opinion, despite their potential, solid-state batteries still face significant challenges. So the question remains, between Tesla's 4680 battery and Toyota's solid-state battery, who will be king? Tesla is rapidly ramping up production of the 4680 battery, currently manufacturing over 500,000 cells per day across its facilities. For now, with Toyota's solid-state battery still not widely available, the 4680 remains the best battery on the market exclusively from Tesla, with no serious competitor yet that truly worries Elon Musk. But that doesn't mean there's no reason for concern. Many other companies are proving strong results with solid-state batteries, including Samsung, Solid Power, and QuantumScape, and Toyota's solid-state battery is no exception. We believe it's important to first understand the basic concepts of these two types of batteries, as that's the root of the issue. We'll try to explain it as briefly as possible. Simply put, every EV battery consists of four main components: an anode, a cathode, a polymer-based separator, and an electrolyte. However, what makes solid-state batteries different from most current battery technologies and potentially revolutionary is that instead of using a liquid electrolyte, they use a solid one. Liquid electrolytes are found in all lithium-ion batteries, including the 4680. So essentially, that one change, the use of a solid electrolyte, completely transforms the nature of the battery. The 4680 battery was first announced by Elon Musk in September 2020, and to date, is only used in the Cybertruck. Fundamentally, the Tesla 4680 is still a cylindrical lithium-ion battery with a diameter of 46 millimeters and a height of 80 millimeters. Its cathode is primarily composed of nickel with 81.6%, the remaining 20% made up of manganese and cobalt. The anode uses silicon instead of graphite, and the cell's characteristics show very strong performance specs. The 4680 battery stands out not only for its optimal size and structure, but also for its innovative tabless design. This design eliminates the traditional tabs that connect the anode and cathode within the battery, offering a range of significant benefits. By doing so, the battery achieves higher energy density, reduced internal resistance, and a simplified manufacturing process, allowing Tesla to lower costs and boost performance. Meanwhile, today's solid-state batteries come in various shapes, including cylindrical, prismatic, pouch, and even thin film types for small devices like earbuds or smartwatches. However, the most common formats are prismatic and pouch cells, which optimize space in EVs and energy storage systems. Solid electrolytes in these batteries are primarily made from three main types of materials: oxides, sulfides, and polymers. So who will win the race for energy density? There's no denying that the competition around energy density is becoming increasingly fierce. with battery technologies constantly evolving to deliver more power in the same volume or weight. Higher energy density means a battery can store more energy, enabling electric vehicles to travel farther on a single charge, an essential factor in expanding EV driving range. The latest generation of Tesla's 4680 battery marks a major leap in energy density, reaching levels of 300 to 350 watt-hours per kilogram, compared to the traditional 2,170 lithium-ion batteries' 260 watt-hours per kilogram. This represents a 15 to 35% improvement in energy storage capacity. Thanks to its dry electrode manufacturing process, the 4680 not only boosts energy density, but also offers exceptional advantages in performance and production cost. According to Tesla, the 4680 battery can increase an EV's driving range by 16% thanks to its high energy density and tabless design, a significant improvement over traditional batteries. When combined with innovations like cell-to-chassis integration and advancements in battery pack design, the range can increase by another 14%, bringing the total range improvement to nearly 30% over conventional battery systems. A clear example of this is the Tesla Model 3. With a 75 kilowatt-hour battery pack, the sedan can reach a range of 363 miles and weighs about 4,000 pounds using traditional LFP batteries. However, with 46,080 cells, the range could increase to 471 miles, while the vehicle's weight drops to around 3,600 pounds. That's a major upgrade not only in range, but also in overall performance and weight efficiency. While Tesla's 4680 battery is primarily focused on outperforming competitors in terms of efficiency, especially with its longer range and lighter weight, solid-state batteries come with an even greater ambition: to create electric vehicles with range equal to or even exceeding that of internal combustion engine vehicles. And in fact, this is not such a far-off goal. The energy density of solid-state batteries today is truly impressive. CATL, the world's leading battery manufacturer, has launched a solid-state battery with an energy density of up to 500 watt-hours per kilogram. Samsung reached a similar milestone earlier this year. In the US, Solid Power has made its mark with a solid-state battery based on a sulfide electrolyte, achieving 500 watt-hours per kilogram in a 100 amp-hour cell. This battery offers superior thermal stability and boosts energy storage by 50 to 75% compared to traditional lithium-ion batteries. One of the standout companies in this race is Toyota, as they plan to double the energy density of solid-state batteries compared to current lithium-ion models, aiming for 600 watt-hours per kilogram by 2026. If successful, Toyota's solid-state battery would have twice the energy density of Tesla's 4680, which would mean Toyota's EV range could potentially reach 750 miles, bringing them closer to reclaiming the lead from Tesla. Furthermore, recent sources indicate that Toyota plans to develop solid-state EV batteries with a range of up to 923 miles. If this becomes a reality, Tesla will face a significant challenge. With such outstanding energy density, solid-state batteries clearly have the potential to dominate the electric vehicle market in the future. However, it's important to note that higher energy density doesn't automatically mean faster charging times, an area where Tesla still leads with its fast-charging technology and manufacturing processes. So, how's the charging time? When it comes to charging speed, insiders at Toyota say their prototype solid-state battery has a clear advantage over current lithium-based batteries, able to charge from 0 to 80% in just 15 minutes. That means customer concerns about long charging times, sometimes stretching for hours, could soon be a thing of the past. The charging speed Toyota promises is nearly on par with the Shaanxi superfast LFP cells from CATL. Solid-state batteries use solid electrolytes made from metal oxides, metal sulfides, or solid polymers. Sulfides, in particular, are softer materials, and this softness plays a key role in allowing lithium ions to move more easily. Oxide-based electrolytes, on the other hand, can handle higher voltages, meaning they can push more ions through the electrolyte for better performance. However, Toyota's solid-state battery faces major challenges in achieving this fast charging speed. One of the biggest issues is dendrite formation, a serious problem that develops much more rapidly in solid-state batteries. Dendrites are branch-like structures that can grow between the battery's electrodes, potentially causing a short circuit. To this day, it remains somewhat of a mystery how soft lithium dendrites can pierce through what should be a hard, solid electrolyte layer. In simple terms, frequent fast charging can make solid-state batteries more prone to short circuits, causing performance degradation faster than conventional lithium batteries, which handle stable charging rates more reliably. So, is Tesla's 4680 battery the better option? With Tesla's 4680 battery, we've observed that both the anode and cathode use full polarity tabs. This design significantly shortens the path of current flow, allowing electrons to move more efficiently through the battery. As a result, the internal resistance of the 4680 battery is only 1/5 that of the 2170 battery. This means the 4680 charges significantly faster than the 2170. According to real-world testing, it takes just 20 minutes to charge the 4680 from 0 to 60%. When paired with an 800-volt electrical architecture, the charging speed improves even further. Currently, the Cybertruck uses 4680 batteries and can charge from 10% to 80% in just 30 minutes, despite having a massive 123 kilowatt-hour battery pack. Before the Cybertruck, some Tesla Model Y vehicles were also equipped with 4680 cells and showed impressive charging speeds. One owner reported driving their SUV to a supercharger station in California with 0 range remaining, and in just 32 minutes, the battery was charged up to 80% using a 250 kilowatt charger. There's no denying that solid-state batteries charge faster than Tesla's 4680. That alone could be enough to convince impatient EV drivers who don't want to wait around. However, that's not the whole story. Now let's talk about safety, because that's the question many people will ask. Which battery is safer for EVs? Tesla's 4680 battery is highly regarded for its safety, thanks to several standout features. First, its simple design eliminates tab connections, reducing the risk of short circuits and improving overall system stability. Second, the thicker steel casing offers better protection for the battery cells against impacts and vibrations, thereby increasing durability and safety. Finally, the 4680 battery's integrated cooling system helps regulate temperature effectively, minimizing the risk of fire or explosion. The clearest evidence of the 4680's safety is seen in Cybertruck accidents, where despite severe vehicle damage, even near total destruction, the trucks rarely catch fire. However, since the 4680 still uses liquid electrolyte, it's not completely safe, especially when compared to solid-state batteries. Solid-state battery technology is praised by experts for its safety, as replacing the liquid electrolyte found in lithium-ion batteries with a solid one significantly reduces the risk of leakage. To put it simply, in lithium-ion batteries, the liquid electrolyte allows lithium ions to move between the positive and negative electrodes during charge and discharge cycles. But like any other liquid, this electrolyte layer is sensitive to temperature fluctuations. You may have seen batteries swell in the middle or even leak some electrolyte fluid, and that's really bad. If the electrolyte evaporates or leaks out, it can cause a short circuit between the positive and negative electrodes, potentially leading to a fire or explosion. If that starts happening underneath your car floor, you're in for a very bad day. So compared to the 4680 battery, solid-state batteries have a slight edge when it comes to safety. Don't get us wrong, both are considered safe, as each type of battery has its own unique design and safety systems to prevent failures. Even solid-state batteries aren't perfectly safe. If you're looking for a longer, lasting, and safer option, Tesla's 4680 battery actually has an advantage over solid-state batteries due to its more stable charging behavior and lower risk of dendrite formation. One of the downsides of solid-state batteries is their relatively short lifespan, and manufacturers are still working to improve the materials. Solid-state batteries still need further development to completely eliminate risks like thermal runaway under extreme conditions, such as temperatures over 300 degrees Celsius, or internal short circuits caused by dendrites. Even so, they pose far fewer risks than current battery technologies, and creating EVs that don't catch fire is a huge win for drivers. Toyota's solid-state batteries appear to have two strong advantages over Tesla's 4680 cells: energy density and charging time, both good enough to potentially lead the entire industry. However, the production cost of these batteries remains a nightmare for manufacturers, and that's one of the biggest obstacles preventing them from hitting the market. According to Toyota, they claim their solid-state batteries will have production costs that are 50% lower. But don't get me wrong, that doesn't mean they'll be 50% cheaper than today's lithium-ion batteries. It simply means they'll be 50% cheaper compared to Toyota's original cost estimates for producing solid-state batteries. As it stands, solid-state batteries can't compete with lithium-ion batteries when it comes to cost. The materials used in solid-state cells are extremely expensive. For example, lithium sulfide, a promising solid electrolyte, can cost 5 to 10 times more than lithium carbonate, not to mention the strict purity requirements for ceramic electrolytes, which further complicate and drive up the cost of manufacturing compared to current battery technologies. To bring solid-state batteries to market, companies must solve not only performance challenges, but also rebuild the entire battery production ecosystem. While Toyota claims it can cut production costs in half, that doesn't mean solid-state batteries will be half the price of current lithium-ion packs. In reality, producing them requires extremely controlled environments, dry rooms, and strict humidity controls, which add significant costs to assembly. The second major barrier is mass production capability. Creating a thin and uniform, solid electrolyte layer is a significant technical challenge. Most major companies like Toyota and QuantumScape have only seen promising results at the lab or prototype stage. A stable, large-scale manufacturing process has yet to be achieved, and any defect during assembly could pose safety risks or severely impact battery performance. The third challenge is durability. Some solid-state battery prototypes currently last only around 1,000 charge cycles, while commercial products are expected to last several thousand. On top of that, there's the issue of dendrites, lithium crystals that can grow through the solid electrolyte and cause short circuits. Even though solid-state batteries are generally considered safer, dendrites remain a major concern, especially when using lithium metal anodes. Finally, material compatibility is another significant hurdle. Not all current cathode materials work well with solid electrolytes. This means companies might need to redesign electrodes or develop entirely new materials, which could lengthen development timelines and increase costs. While solid-state batteries hold massive potential, they still face serious challenges in terms of cost and manufacturability. Meanwhile, Tesla's 4680 battery, as mentioned earlier, is already being produced at scale, with over 500,000 cells reportedly manufactured daily across its facilities. This suggests the production lines for the 4680 are relatively efficient. Currently, Tesla is only using the 4680 in the Cybertruck, and the truck's performance has been genuinely impressive. That said, it's still unclear why Tesla hasn't extended 4680 use to its other vehicle models. What's your take on that? Although Tesla hasn't disclosed the exact production cost of the 4680, analysts estimate the current price ranges between $114 and $170 per kilowatt hour. Elon Musk has stated a future goal of scaling 4680 production up to 1,000 gigawatt-hours per year, with costs potentially dropping to $70 per kilowatt-hour, an ambitious but bold target. Tesla continues to push aggressively toward this goal and has already achieved an impressive rate of progress. In conclusion, both solid-state batteries and Tesla's 4680 cells are revolutionary technologies that are pushing the EV industry forward. Solid-state batteries, with their superior energy density, fast charging capability, and enhanced safety, have captured the attention of both manufacturers and consumers. This technology is widely seen as the future of EVs, especially because it addresses key safety concerns associated with lithium-ion batteries, such as fires caused by liquid electrolytes. However, high production costs, a lack of standardized raw materials, and complex manufacturing processes remain major hurdles. For now, solid-state batteries are mostly limited to high-end EVs. On the other hand, Tesla's 4680 battery, while not yet reaching the energy density breakthroughs of solid-state tech, stands out as one of the most advanced and practical batteries currently available. Tesla is rapidly scaling up production of the 4680, aiming to lower costs and increase volume, a strategy that helps the company maintain its leadership in the EV market.